So there's two major ways to find the slope of a linear function. One is rise over run, and the other is with what's known as the slope formula. So this is going to tie the two together. So um, it says to find the slope of the graph, Aiden chose the 2 points shown. Okay, so here's our 2 points, uh, and counted the rise to be 2 and the run to be 6. So obviously that's a rise of 2, a run of 6. It's going upwards, so it's positive. And then when he reduced it, rise over run, simplified down to 1/3. Okay, that all checks out. Okay. Now it says using the values in the ordered pairs, how else could Aiden have found the rise to be 2? Okay, so where are we? So let's work with the rise. The rise is on the y-axis, right? On the y-axis. So we have a 5 for the first value of y. We have a 7 for the second. Okay? So using the numbers 7 and 5, how can we get a value of 2? Yeah, by subtracting. And those are what we have. We have 7, take away 5. That equals 2. Okay. And then the same thing with our run values, which are 3 and 9. We went from 3 to 9. And if we subtract a 3 from a 9, don't we get a 6? And so lo and behold, the rise was 2, the run was 6. We also get 1/3 that way. But what we're really doing is using the slope formula. Okay? So this is the slope formula. And typically I even used it here, I noticed. You see what variable I used? M. M is commonly known in the field of math, whenever we give it a specific value or term, as the slope. So we even substitute M for the word slope a lot of times. Okay? And what are we doing with the y values? Subtracting. So this is the difference in y values. Write this down. Difference in y's. Same thing in the denominator. This is the difference in x's. Okay? And so what we're doing, if you're wondering what do the 2's and the 1's mean, they don't mean exponents. It doesn't mean y times y or y times y, y times 2 or anything like that. It's just saying the second of 2 y's, the first of 2 y's. Same thing with the x's. The second of 2 x's, the first of 2 x's. It's just giving them an order. Okay? So these are called subscripts, and they don't tell you to do anything mathematically. They're just telling you which x and which y they are. Okay? So what we're going to do next is we're going to use this formula to find the slope of the graph line. So before we even do anything, should our answer be a positive slope or a negative slope? Negative, it's going downwards. So we got to expect a negative number. All right, so I'm going to zoom in a little more. And let's go ahead and let's pick some points. All right, so I'm going to pick maybe this. No, that's not a good value. That's a tough. Oh, yeah, it is. I'm going to pick this one, at 3, 5. So I'm going to pick the value 3, 5. And then I got to pick another value further down. How about this one at 6, 3. All I did was pick some values. Go ahead and write those down and make those dots. Let's all do the same values. All right. So let's call this my x1 and y1. So that's the first x and y. And we'll call the other one x2, y2. x2 is this one, y2 is that one. And we're going to do this. Scoot, scoot, scoot over. We're going to use this formula. I'm going to give you basically a shortcut for this. So m equals a long fraction bar. Then we're going to subtract on the top, subtract on the bottom. Go ahead and write that down. Now, placing the numbers correctly is one of the more challenging things here. So I'm going to take, since I noticed, and do you notice y2 is on top of x2? Do you see that? Yeah. And they're the first ones. And then y1's on top of x1, and they're the second ones. So I'm going to take this second ordered pair. Imagine you rotate it. You know what I mean by rotate it? Turn it so it's up. One number's on top, one number's on the bottom. So I turn it counterclockwise 90 degrees. Which number would be on top if I turn it? Which number though? 3. Which number would be on the bottom? So 3 goes here, 6 goes there. We do that with our second ordered pair. Okay? So 3 goes here, 6 goes there. But you were very correct, Ariane. The y is the top number because that's what I want in the formula. Okay? Let's do the same thing with, so we already took care of this one. Let's do the same thing with 3 and 5. Rotate it, 5 over 3. Okay? Now let's do the subtraction and get an answer. So now we're going to do 3 take away 5. Notice what I'm doing. 3 take away 5. -2. Yeah, that's going to be a negative because you're taking away more than you have. It is the absolute value as 2, but it's a -2. Okay. Now let's do 6 take away 3. And basically that's the answer we should get. Because let's try this with rise over run. Okay? If we do rise over run, we're going to go down 2 and across 3. Isn't that -2 over 3 also? Yeah. So there's 2 ways to do a graph, get the slope. If you can make a graph, or if a graph's provided, rise over run is the easiest. Go with that. But if all you have are the coordinates, then use the slope formula. So we're going to practice using the slope formula today, okay? So I'll give you a minute to catch up with all of this. And we're going to practice 4 of these, and then we'll look at the assignment. Okay? I see some people. Anybody still writing? Okay, vamos a empezar. We have 4 here. We're going to set up the formula, work it out, and then we're going to write the slope answer. Okay, here we go. For all of these, we're going to make this x1, y1, and that's typical. The first ordered pair is your x1, y1, and the second one's your x2, y2. Okay? Let's just set this up and get an answer. Okay, so we're going to do okay, And we're going to start with this one. Rotate it 90 degrees counterclockwise. 7 and 1. And they go first. Okay? So 7 and 1 go here. 7, 1. Now take the first ordered pair, do the same thing, and they go in the second slot. 4, 2. 4 goes on top. 2 goes on the bottom. Okay, let's work out what we get as an answer. 7 minus 4. That's 3. 1 take away 2. Negative 1. So our answer is either 3 over negative 1, or what happens when you divide 3 by negative 1? So it's either 3 over negative 1 or negative 3. Okay? And that's it. We found the slope. This line would go up 3 and to the left 1. Okay? Let's go on to number 2. Same deal. Fraction bar, minus, minus. And I see I have some negatives. All that means is I'm going to do keep, change, flip. Remember how you change subtraction problems to addition? Keep, change, flip. We're going to practice that. Okay, so here we go. We've got x1, y1, x2, y2. Okay, so we'll take the second one, turn it 90 degrees counterclockwise. Which number goes on top? Negative 5 goes here. Positive 5 goes there. Okay, we're on to a good start. Now we're going to do x1, y1. Do the same thing. Turn it and put it in. So which one goes on top? 3 or negative 1? 3 and then negative 1. Whenever I see a minus and a negative 1, I'm just instinctual. I do that. Now, anytime I see negatives in my subtraction problem, I do keep, change, opposite. Okay, turn it into addition. It's just easier for me to process. So remember how we do this? Keep this, change this to addition. So now we have a plus sign, and then flip the sign on this one so it becomes negative 3. So what's negative 5 plus negative 3? Negative 8. Now we're using the rules for addition. And I'm going to do the same thing here. Keep this, change this, flip this. So now it's just 5 plus 1. 6. And of course, I see they're both even, so I can at least divide by 2. Whenever both your numbers are even, try dividing by 2. And if I do that, I get an answer of negative 8 divided by 2 is negative 4. 6 divided by 2 is, so the answer is negative 4/3. Okay? So I can already picture the line. Down 4, across 3. Okay? All right. Let's try the next one. I'd like you to try setting up this one on your own. Okay? Here's your numbers. Let's make this x1 and y1, x2 and y2. Okay? All right. Go ahead and set it up, and then we'll answer it. Okay, so on your own, try it. But I have 22 minus 11 and 10 minus 8 in the denominator. So let's do the subtraction. 22 take away 11. That's 11. 10 minus 8, that's going to be 2. Now, that's our answer, right? I can't reduce 11 halves. Now, a big urge, because of how you were taught, is, oh, I got an improper fraction. I need to write this as 5 1/2. Don't do that here. Don't do that for slopes, please. Here, we're going to say it's 11 over 2. Leave it improper because it means this ratio means something. It means we go up 11 across 2. Okay? So that's why we leave it as an improper fraction. Okay? All right, one more and then we'll do the assignment or work on the assignment. I want you to try setting this one up as well. Same thing, we'll make this x1, y1, and then x2, y2. Okay? So let's try putting those numbers correctly into the formula. What you got? Okay, so now let's try getting an answer. So 6 minus 9, negative 3. And then it's not so obvious until I do keep change flip. So I'm going to keep change this to plus, flip this to positive 1. What's negative 1 plus positive 1? 0. Now, the big question comes up. What is negative 3 divided by 0? Well, that was true yesterday when we had 0 divided by, I forget what. But 0 over or divided by some number, when 0 is on top, that's when we get 0. Here, let me show you what the calculator tells us. Okay, so I have here negative 3 divided by 0, and it tells me divide by 0 and error, because you really can't divide by 0. It's undefined. So this would actually literally give us a vertical line. Remember we said that when the slope is undefined, the line goes straight up and down? That's what we have here. It's going through negative 1 on the x-axis. So the problem with dividing by 0 is 0 can go into anything, any number of times you want. 0 can go into negative 3 an infinite number of times. So that's why it's undefined. So this is a special case. It's undefined. So if the 0 is on top, what's the answer? 0. If the 0 is on the bottom, what's the answer? Undefined. Okay? All right. Because that is going to come up on today's assignment. All right? So is anybody still writing this?